In number 9, we have some fractions within fractions. So we want to eliminate those expressions. So what we do is find a common denominator between every rational expression. So we have a denominator of 10x, 5, and 4x. So we need to find a number that goes into all 4 of those numbers. So since 10, 5, and 4 all go into 20, 20 will be the coefficient we need, and since x and x are the variables, they both go into x, so the common denominator is 20x. So we have to multiply the numerator and the denominator by 20x. So if you distribute the 20x to x over 10, you're going to end up with 20x times x over 10, and then we'll do minus 20x times 3 over x all over 20x times x over 5 minus 20x times 1 over 4x. And that's the expanded way to write this. Again, you can do that in your head. I just wrote it out so that you can see it. Okay, so the x's do not cancel. They're both in the numerator. This is over 1. The 10 and the 20 cancel. The 10's gone. The 20 becomes a 2. So now we have to multiply 2x times x, which is 2x squared. We're going to keep our minus sign. Now the 20x and the x cancel. The x's cancel. So we're just going to have 20 times 3, which is 60. Divided by, over here, the 5 and the 20 cancel. The 20 becomes a 4, so we have 4x times x, which is 4x squared. Keep our minus sign. The x's cancel, the 4 and the 20 will also cancel and become 5. So we have minus 5. So that cannot be factored, so that's our final answer. 2x squared minus 60 over 4x squared minus 5. Okay, over here, number 10, we have the same type of problem. We have a denominator of 1 here and a denominator of 1 here. So again, we're looking for a common denominator. So we have an x, a 1, and an x minus 1. So the number we're going to have, or the expression we're going to have to multiply by is x times x minus 1, and we'll have to do that to the numerator and to the denominator. Okay, so if we multiply this whole expression by 2 over x, the x's are going to cancel, and I'm going to be left with 2 times x minus 1, and then I'll do the minus 3, and then here we're going to have to multiply by everything because nothing cancels with the 1. So 3x times x minus 1 over, again, the 1 does not cancel with this denominator, so we're just going to be 1 times x minus 1 minus, here the x minus 1's will cancel, so it's going to be 1x. And then we can just simplify this expression. 2 times x is 2x. 2 times negative 1 is negative 2. Now I'm going to take this negative 3x and distribute it through the x minus 1. So that gives us a negative 3x squared plus 3x times negative, or negative 3x times negative 1 is a positive 3x. Okay, over, I'm going to distribute the x here. So x squared minus x minus another x. So we'll simplify this expression here. Get a negative 3x squared, add together our x terms, which is a positive 5x minus 2 over x squared minus 2x. And if we wanted to, we can factor out this denominator, but it's not going to help us cancel anything up here, so we can just leave it this way. if you did factor, the answer is going to be, you can factor out a negative here. Negative 3 times x squared minus 5x plus 2 over, take out an x and you'll have an x minus 2 remaining. So this could be the answer as well. Either one works. So either one of these answers would be acceptable. Okay. So now in number 11, we will be solving. So we're going to have to include a domain, and to get a domain, we are not allowed to divide by 0. So we have to find any number that, if the solution is that number, would make this an undefined equation. So we have to set up a domain to find out what our restrictions on x are. So if we take this denominator, just x, the only number that would make this 0 is 0. So our domain is going to be x's such that x cannot equal 0. And this one also cannot equal 0 because 2 times 0 is 0. So the only restriction on our domain for this problem is x cannot equal 0. Now to solve an irrational equation, we want to get rid of the fractions. So we will use the same strategy that we used in the previous problems by getting a common denominator and multiplying every expression, every term by that denominator. So what does x, 2x, and 6 all go into? Well, that is 6x. So we're going to take a 6x and we're going to multiply it by every term in this problem. So we're going to distribute to all three of these expressions. So 6x times 2 over x plus 6x times 3 over 2x equals 6x times 7 over 6. And then we can just reduce. The x's cancel here, we're left with a 12. The x's cancel here, the 2 and the 6 cancel, we're left with 3. 3 times 3 is 9. The 6's cancel here, and we're left with 7x. So 12 and 9 is going to be 21, so that's going to equal 7x. So x is equal to 3. We have to check to make sure that's not in our domain restriction, and it's not, so the solution is x equals 3. Over here in number 12, we just have a proportion, so we can just cross multiply and set them equal to each other. So we can have 9y is equal to 5 times 2y plus 1. Simplify this out, or expand this out, 10y plus 5. Get y's together on the same side, so that's going to be a negative 1y equals 5. So y is going to equal negative 5. And we have to go back and set a domain. The restriction for the first value of y is again 0. We can't have the denominator equal to 0. So the domain is going to be y such that y cannot equal 0. And over here, we can set up a restriction. If you can't do that in your head, you just need to figure out what 2y plus 1 equals 0 is. We have to figure out what makes that 0. So we're going to solve this simple equation, and the answer is negative 1/2. So y cannot equal negative 1/2. Since negative 5 is not in this restriction, y is equal to negative 5 is our solution.